stoichiometry, like we learned, is the quantitative relationships between reactants and products. And when we say quantitative relationships, it could be mole to mole relationship, as in moles of reactants to moles of products, or mole to mass relationship between moles of reactants, moles of products, or moles of products to mass of reactants, and relationships between mass of product and mass of reactant. Okay, so let's first learn about the mole-to-mole relationships, and then we will generalize it to mole mass and mass-mass relationship. So let's take an example reaction: nitrogen gas plus hydrogen gas yields ammonia. Say we have 4 moles of nitrogen gas and 9 moles of hydrogen gas, okay, at the beginning of the reaction. Okay, in present, 4 moles of nitrogen gas and 9 moles of hydrogen gas. So at the very beginning of the reactions, there will be 0 moles of ammonia because we did not start the reaction yet. Once the reaction is done, how will you know how much of nitrogen got consumed and how much of hydrogen got consumed and how much of ammonia do we have? So the mole ratio here is 1 to 3. For every 1 mole of nitrogen, 3 moles of hydrogens are being used. So if we have 4 moles of nitrogen, technically we would need 12 moles of hydrogen. But we don't have 12 moles of hydrogen, right? We have only 9 moles of hydrogen. So how does this work? How do we calculate how much of ammonia is produced? So let's think of it from another perspective. If there are 9 moles of hydrogen present, how many nitrogen would you use for that? If there are 9 moles of hydrogen present, you would use 3 moles of nitrogen, right? So then 3 moles of nitrogen will get used up and 9 moles of hydrogen will get used up. So 1 mole of nitrogen is left over, 0 moles of hydrogen is left over, and in that process you should also remember it's a 1 to 3 to 2 ratio. That means for every 1 mole of nitrogen consumed, there will be 2 moles of ammonia gas produced. So if 3 moles of nitrogen is consumed, using up 9 moles of hydrogen according to the mole ratio, there will be 6 moles of ammonia produced. So you will get 6 moles of ammonia as your yield of product. Yield is always for product. There will be 1 mole of nitrogen left over and all the hydrogen is consumed. So you have to remember that there's one reactant that gets used up, and the reactant that gets used up is known as the limiting reactant. And the amount of product that is formed according to calculations, and please make sure to remember this, according to calculations, how much of ammonia is produced, how much of product is produced, that is known as the theoretical yield of the product. So there are 2 terms, limiting reactant and theoretical yield. What is limiting reactant? Limiting reactant is the reactant that gets completely used up in a reaction, and theoretical yield is the amount of product that is produced when we work on the calculations. When we calculate, take the amount of reactant, and if we calculate the amount of product, the answer we come up with will be the theoretical yield of product. We insist on theoretical yield of product because there is also another term known as actual yield of product. What's actual yield? Actual yield of the product is the amount of product produced when the reaction is actually carried out. When the reaction is actually performed. And what's the difference between theoretical yield and actual yield? When you calculate, it's ideal situation. But when you actually work on the reaction, there can be a number of things that can affect them. The temperature can affect them. Pressure of gases can affect. In some reactions, light can affect the reaction. So you would think that all that you calculated theoretically would be produced, but reactions, when you perform them, they are not 100% efficient. Right? They are not 100% efficient. There's only certain percent of theoretical yield that will be formed. You will not get all the 100% of theoretical yield. Right? So, what is the efficiency of the reaction? Percent yield efficiency of the reaction is actual yield divided by theoretical yield multiplied by 100. That will be the percent yield of the reaction. Go over this video a couple of times using and try to get used to the terms actual yield, theoretical yield, limiting reagent, percent yield, and we'll work problems in the next few videos and also in class.